All right, ladies and gentlemen, recording has started. So if you're whispering in the corner, the microphone can pick you up and tell how distracting you are to everybody else in the classroom. Just saying. So, yesterday, we talked about the development of the periodic table. And we said that the one person who is most given credit for developing the periodic table is a Russian guy named Dmitry Mendeleev. Okay? So, Mendeleev takes the elements that we knew at the time, which was in low 60s, and arranges them in order of increasing atomic mass. Is that how we arrange our periodic table today? Our periodic table today is arranged by increasing atomic number. But there was a problem. Mendeleev didn't know about atomic number because we're talking about the 1860s, right? Thomson doesn't discover the electron until 1897, right? So Mendeleev doesn't even know that an atom has parts inside of it, right? To him, it's just a solid sphere. But they did know the masses because the mass just compares this atom to that atom. It doesn't take into account what's inside of it. We didn't know why one was heavier than the other one. We just knew that they were, right? So Mendeleev develops his table. He goes by atomic mass, not by atomic number, because he didn't know about protons. He didn't know about the nucleus of an atom, right? All he had to go by originally was this atomic mass of comparing one atom to another. Of course, today, right, we talked yesterday at the end of the period about a guy named Henry Moseley who develops a way to actually tell how many protons are in each nucleus. And so today, we arrange our modern periodic table by increasing atomic number, and we see that some of the things that Mendeleev maybe couldn't explain sort of get resolved. I think yesterday I talked to you guys about iodine and tellurium, right? That if you look at them, that tellurium has a lower atomic number than iodine, but a greater atomic mass. So if Mendeleev just went by mass, he would have put them in opposite order, but he knew properties-wise they were different from each other, similar to other things, and that's why he arranged them the way he did. Okay. Good there? All right, so that's one big change as far as our periodic table goes from when it was first developed to now. Okay. All right, let's talk about a little information. Okay. Every periodic table that you're going to find is going to have at least 3 of these 4 things. Most periodic tables are going to have all 4 of these things. Some periodic tables, like yours from your planner, have a lot more than these 4 pieces of information, but it's going to have at least these 4 things. So, first, what's letter A going to be? That's the atomic number for that element, right? We said the atomic number is important because why? How many protons it has, right? And that's what tells us what kind of atom it is. Okay? Letter B. Going to be the atomic symbol or the elemental symbol, right? Doesn't really matter whether you call it element or atomic, same thing. Okay? And then C is going to be the name, the element name. Okay? And then D, we said that D actually serves 2 functions, all right? What is D actually? The average atomic mass, right? And we talked about that the average atomic mass takes into account all of the isotopes of that element, right? And it averages out their atomic masses. Atomic mass applies to one specific isotope. Average atomic mass applies to the average of all of them. Okay? So that's what letter D is. But we said letter D also helps us out with something else, right? What does letter D also help us out with? What else could letter D be labeled as? We could kind of use that to figure out, but that's not exactly what it is. What else could letter D? We've used letter D for something else before. Noor, what else have we used before? The molar mass, right? We said that that number is how many grams of that element are in 1 mole of that element, right? Do we remember that from last one? Okay. So it's the average atomic mass, but numerically it's also the molar mass. Okay? All right, good there. So let's let's start talking about this table here, okay? All right, let's go here, let's go here, okay? So periodic table, right? Two ways that we describe these elements, rows and columns. First, are we okay with the difference between rows and columns? Because some people aren't, okay? Rows are side to side, columns are up and down, okay? Just make sure we're clear, okay? All right, rows on the periodic table. Rows on the periodic table are called periods, okay? And you will see that each period is labeled with a number that is equal to the principal quantum number. And that will become more important here in just a second when I do the next thing that we're going to show you. Okay? And so on your periodic table, right, we go back here, right, 1, 2, 3, 4, 5, 6, 7. Those apply to the different rows on the periodic table. Okay? Next, columns go by two names. Sometimes we call columns groups, sometimes we call them families. Either one is perfectly fine. They are used interchangeably. It's not that one is more important than the other one. Same thing. Okay? So groups or families. In labeling the groups or families on the periodic table, we basically start on the left-hand side and just go from left to right, label them 1 through 18. Okay? So if we got here's our periodic table, right? This is group 1, this is group 2, this is group 8, this is group 14, this is group 17, this is group 18. Okay? And we refer to them as such, right? You know, group 14, group 16, group 17, okay? Some of those groups have names, and we'll learn some of those names tomorrow, but if you say group 14, everybody will know, boom, you're talking about this one, okay? These ones down at the bottom, the green ones, actually get left out of that numbering system, okay? And there's a reason why. We'll talk about that a little later, okay? But keep in mind that if you see an older periodic table, there are some other ways that they will label the columns. They will use a system of Roman numerals and letters to distinguish the different columns. Generally, the short section right through here, okay, these will get labeled as B, so you'll see like Roman numeral 1B, Roman numeral 2B, Roman numeral 3B, kind of go across like that. But then the tall columns, so these two, and then these 6 over here are sometimes labeled as A. So this is like Roman numeral 1A, and this is 2A, and then it skips, and this is 3A and 4A, right? So just know that exists, but most of the time we just go left to right, 1 through 18, and that's good. Okay? Good there. All right. For the next part, what I would like you to do is, using your chart for orbital filling, I want you to write for me 3 electron configurations. 3 electron configurations for lithium, sodium, and potassium. So using your chart of orbital filling that we used in the last chapter, this is not a turn-in thing. If you want to do it like on the side of your notes or in just some empty space down at the bottom, that's fine, just so we can look at them and compare these electron configurations. So electron configuration for lithium, sodium, and potassium. As you guys are working on that, I will slowly start putting answers up on the board so you can check and see how you did. answers, don't look up on the board because they're up there right now. So once you finish, go ahead and look up on the board and see how you did. All right, how do we do with these three? Okay here? All right, in looking up lithium and sodium and potassium on the periodic table, what do you notice about them? Where are they? John, go ahead. They're all right after a noble gas. Where are they in relation to each other? We would say that they are in the same group or the same family, okay? And so we look on our periodic table, and there's lithium, there's sodium, there's potassium, okay? If we look at their electron configurations, right, what are we seeing about their electron configurations? No, go ahead. They all end with one electron, and that one electron is in which orbital, or what kind of orbital? The s orbital. The only thing that makes it different, Noor, is what? Its principal energy level, right? So these all have similar electron configurations, just one ring out from the next, okay? And if you remember, going back here, I said we label the periods, right, by their principal quantum number. And going by these electron configurations, right, lithium is in the second row because it's 2s1, right? Sodium's in the third row, it's 3s1. Potassium's in the fourth row, it's 4s1, right? If you had to make a guess about cesium, what would you think its electron configuration is going to look like? 6s1, okay? There is a pattern there, all right? Next, what do I want you to do? Just timing in my head. Okay. That's not good. All right. So, what we find out is if we go down a family or a group and we look at the elements in the group, we see that they have similar chemical properties because they have similar what? What do we? Not quantum numbers. They have similar electron configurations. That arrangement of electrons leads them to behave similarly to other elements in that group. And that is where Mendeleev, well, he didn't come up with this, but we know now today that that similar arrangement of electrons is what leads us to this idea of the periodic law that we talked about yesterday, right? That elements start having similar patterns, and so we put them together in groups. What we know now today, and we'll see why, not next unit, but the following unit, when we talk about bonding, is that because of these electron arrangements, that leads them to have similar properties. Okay? Good there? Here, you don't have to write this down, this isn't on your chart, but what we see is, right, all the elements in group 1, like we just saw, end in NS1, where N represents what? The principal quantum number, which also would relate to what on the periodic table? What row they're in, okay? That elements in group 17 all end in NS2, NP5, okay? And we'll talk about that more when we talk about bonding and why that is and how it's important, Okay? So we see that their electron configurations for elements within the same row, or sorry, the same column are all similar. And that leads them to having similar properties. Okay? Sorry, too far. Okay. All right, finish that up there, right? That the repeatable pattern of properties is the result of similar electron arrangements or electron configurations in all elements of the same family. And that leads us to this idea of periodic law. The electron configurations are more the theory behind the periodic law. Does that make sense? All right, it's good there? You ready to go a little low stress for the rest of class? Okay. Get to color? Yeah, coloring. Take a little trip down memory lane, back to, whatever, second grade when you got to color.
Nom.
What?
Nom.
Nom. I don't know if there was too much coloring going on in Nom.
What?
Maybe Agent Orange, but, so.
Still
All right, so what we will find here is that on the periodic table, there are 4 main groups of elements. Yesterday, when we did our grouping, our classification activity about the things that were in my kitchen, how did we group things together? What did we look to do when grouping things together? We put things in groups that are what? Similar, right? And that's the case here as well. We'll see that because these groups are large, there is variation among things in that group, but they all are similar in some way. So 4 big groups: metals, nonmetals, transition metals, and then metalloids. Okay? Good? All right, so
Do we
let's
have to
start.
write the inner transition metals?
Intertransition metals, you'll see, shows up underneath transition metals. Okay? So these are the things you're going to color on the periodic table. Okay? All right, so let's start with this. Oh. Okay. Oh, sorry, let's go back here. Sorry. So each section contains elements with similar properties, right? There is something that is similar about the elements within that group. Okay. The last part, letter F, we'll fill that out after we color in the periodic table. Okay? So, starting off, metals. Okay? Metals are a big group of elements that covers a large section of the periodic table. Okay? Definitely the first 2 columns, except for hydrogen up at the top, okay? All of the short section in the middle, okay? And then on the end, if you're using your periodic table that's in your planner, it covers the yellow stuff up into the lime green, okay?
So like some transition. So we're coloring metals and transition metals.
They are all, yes. The transition metals count as metals, Andrew, so we'll see that they are distinguished, like they are a separate group.
So the metals are the wet, and the transition metals are the pinkish.
Yeah, the ones that are X'd out, because transition metals are metals. They count as metals, okay? But they're not, they get classified a little bit differently, okay? So yeah, so if you want to, I mean, Kevin, like, I'll leave this up to you whether you want to color it or not, but you're going to need to know these sections when you get to the test, all right? So, right? Definitely the first 2 columns, definitely the short section of the periodic table, and then if you're looking at your periodic table, up until the ones that are colored lime green. Yes, one.
And like the 2 columns and then this section are different colors, right?
They're technically all metals, although we'll see that that short section gets specified a little bit more. Okay.
So should we color?
Yeah, color it as metal because they're all metals. Okay, and then you'll see that you're going to add a little bit more detail as we go along. Okay, it's like, all squares are rectangles, but not all rectangles are squares. You know what I'm saying? Right now we're coloring rectangles, and then we're going to show squares in a second. Okay, a specific grouping
So just
within
color-
rectangles.
Color the whole thing same color.
Yeah, go ahead. Right, and then say again. Those 2 on the bottom as well. Yeah, everything that's colored red here. Okay.
So what were you talking about? Like metal, only be in the metal for like 2 seconds.
Those gray ones down at the bottom. Alright, next. If we go here. So the ones that are highlighted in yellow, so basically the short section of the periodic table, the 10 columns that are in this quote-unquote short section, plus these two down in the bottom, we refer to as the transition metals. They are metals. They have metal behavior, but we're sort of in that section where they're not becoming quote-unquote as metallic.
But didn't we just like colored them?
Yes, but like I said, these are metals, but they are a specific grouping of metals, okay? If you want to just write over top of it, you can, that's fine. If you want to outline it in a different color, that's fine too, okay? But when I say transition metals, you need to know where I'm talking about.
Yeah, but
okay?
why was... Oh, I get it now.
There you go.
Within these transition metals, within this short section of the periodic table, that is generally where most of the things that you guys would consider metals actually exist. Things like copper and iron and silver and gold. All of those things that you would say, oh yeah, those are metals. Those actually fall in the section that is called the transition metals. They are metals, they are metallic, they're just a little bit different than the other metals that you colored in. The two down at the bottom we refer to as the inner transition metals, and generally those rows go by the name of, or they are grouped by the name of the first element in that group. So the first element down here in this top row on the bottom, I know that's kind of confusing, but this element right here is called lanthanum. And so we refer to this row as the lanthanides. Okay, yeah, go ahead. And then the second row, the first element in that row is called actinium. And so we refer to that as the actinides. That's generally how we refer to those rows down at the bottom. So, transition metals are metals, but not all metals are transition metals. So think about it that way. Exactly. So it is, right? All squares are rectangles, but not all rectangles are squares. Yes. I did say that, yes. I didn't know if you heard me or not. All right, we okay there? The next grouping of elements that we come across are our nonmetals. Okay? We said that the nonmetals, we will actually see a great deal of variation in our nonmetals. The one thing that they have in common is that they're not metals. Okay? On your periodic table, that's everything else except for the ones that are colored lime green along that red line. You know what I'm saying? Okay? The lime green ones don't get colored, the rest of them do. Okay? So your nonmetals are things that nonmetals are the ones that one thing that they have in common is that they are not metals. We see that there is a lot of variation among those nonmetals. Some are solids, some are liquids, some are gases. Some of them are very, very, very reactive, and some of them don't do anything. So we'll see that there's a lot of variation within there, but the one thing that they have in common is that they are non-metals. They are not metals. Okay. And then the last group, the ones that we haven't colored yet, the ones that are lime green on your periodic table, are called our metalloids. Right? If we refer to something as metalloids, that means it's kind of metally, right? But it's also kind of non-metally. So there is a transition between the metals and the non-metals. Okay. Okay, Christine. You can color all those, yes, that's fine. So, although we said that
Including
last.
this one?
Yeah, definitely that one. Although the one on the bottom really is kind of like one of those imaginary ones, you know what I'm saying? So yeah. It's good. Nobody should care about that one, so. Yes, Jim? Okay, like I said, those ones that are on the bottom, that bottom row, those elements are basically imaginary, right? They don't like exist in nature. They're, you know, they only exist for very, very short times in a laboratory, so don't worry so much about those. You're not going to run across those a whole lot.
So we should like that bottom row just not be blank.
You can just leave it blank, that's fine. So, and then, like I said, the last section that we come across, these are our metalloids, okay? Color the ones that are lime green on your chart, that'll be good, and those are the ones that we see that transition between metal behavior and non-metal behavior. Okay? Tomorrow, we talk about individual families on that periodic table and some of the properties of those families. Okay? Don't forget goggles if you're going to buy them. If not, I have some for you to borrow, and that's perfectly fine. Okay? If you borrow colored pencils, please bring them up here. Thank you.